Hey guys, welcome back to Chemchris TV. Good to have you here. Let's look at what Ohm's law under what electric field, and we are still what physics JAMB intensive online class. So if you are writing the upcoming JAMB, then you want to pay attention to me, especially if you are going to write physics, because this where so you are going to see some of your words, your question, and I want to take time to dissect this talk for you, enough for you to understand very well. So make sure you have to pen, your notebook, and your calculator in order to follow up this class. So I've done the first two videos on electric field. So the first video I did the first video I did was called electric currents, where I gave what the formulas in calculating what potential what difference. Then in the second videos we did calculation of what resistors in parallel and see which is under what electrical what circuit. So I explained what's called electric circuit, various component of the electric circuit, and connection of resistors in series and in parallel. And I have to do simple calculation because these are what foundation or basis to this video here, Ohm's law. So let's get into what it's called Ohm's law. So I'll be advised to go check out those videos by the end of this video. Links will be at the description below, right? So let's go. What is Ohm's law? Ohm's law states that the current passing through a metallic conductor is directly proportional to its potential difference across its ends, provided that temperature and every other condition in circuit remains constant. So what I'm trying to say is that even that potential difference, which is V, is directly proportional to what current that pass through the circuit. You get now. Even that as voltage increases, the current actually increases. Do you understand? So to remove this sign here, we have to introduce what constant, which is called R. So V is equal to what I R. So this formula you making use of, where V is called what potential difference. V equals to what potential what difference. Potential what difference. I is what is current that flows. Current. Now this one is measured in volts. Yes, measured in amperes. The arrow is what is resistor. I measure in what in ohms. I measure in what in ohms. So this is what formula what make use of. Yeah, you can make I the formula. Yeah, if you should make I the subject of formula, you have to have I equals to what V over what R. Yeah, if you make R the formula here, you have to have R here equals to what V over what I. Very important here. So these are the formulas for what make use of. Remember I told you this one is what is the current, this is what is the volt, then R is what is the resistance. So we have to now most times you want to see when a circuit or a diagram is being given to you and the resistors can either be connected in series or in parallel. You have to see you have to do those calculations. So make sure you stick to the end of this video here. So let's move into the calculation aspects. So let's take a look at the first set of questions. Question 1, 2, 3, and 4. So let's see how we can solve problems like this when you see them in the exam. So please pay close attention. Remember I told you that Ohm's law states that the current passing through a wire is directly proportional to what? To the voltage, to potential difference, provided that the temperature and every other condition in the circuit remain what? Constant. So here is for like V equals to what I R here. So this is what we want to use in our calculation. So what I will do here, I'll do most of the calculation here. So let's take a look at the first question. If a current of 6.6 amperes, so here my I is equal to 6.6 amperes, right? Was passed through 4.8 ohms. Was passed through 4.8 ohms. So then my resistance is 4.8 ohms, right? The way they say calculate potential difference, so they say we will calculate what V. You can see how easy it is, right? So bring that formula here and use it. V equals to I R, which equals to 6.6 times 4.8. We have to calculate all. So you have 6.6 times 4.8. Here we have what 31. 31.68 what volts. Remember, the unit of potential difference is what is volts. So that is the answer. So that is the answer to what the first one. Very easy, right? So look at what the second one. A car fuse is marked 15 amperes and operates normally on a 12-volt battery. Calculate the resistance of the wire. I believe you should be able to solve this kind of question yourself, right? So pause the video and see how you can solve this video. Sorry, pause the video and see how you can solve this question. You say it's very easy. Do you understand? So leave your answer at the comment section. These are two questions. Leave your answer at the comment section. Please leave at the comment section. I want to see your answer. So I'm not going to answer this one here because I believe everyone should be able to answer this question here. So now, question 3 and question 4 is what will actually give us a tough time here. But although it's not that too difficult, but just pay close attention. If you know how to calculate resistors in series and parallel, then this thing will be more easier for you. You get. So now before we continue here, because let's look at what resistors in series and in parallel. This one is not complete, so let me complete this one. Here we have 10 ohms. 10 ohms. Yes, but let's say 16 ohms. 16 ohms. So let's our question 3. Say the sum of the currents. They're asking you to calculate the sum of the currents in the circuit. Calculate the total current in the circuit. Now look at this circuit here. If you look at the circuit here, we have the volt is 12 volts. Now here we have this resistor here. Here we have this resistor here. Now if you check it very well, now let this one be resistor 1, resistor 2, and resistor 3. You get resistor 1, resistor 2, and resistor 3. Now the session will calculate the total current. So you want to calculate what the total current, which is I. I there. They give us what? V, voltage, V. Our voltage is what? 13 volts. 13 volts. Now, in order for us to calculate what the total current here, we need what the total resistance or the equivalent resistance in the circuit. Do you understand? We need the equivalent resistance in the circuit. Now, the equivalent resistance was not given to us, so we have to do the calculation. Do you understand? So we don't know our watts, we don't know our arrow. So it is our arrow we need to calculate now in order for to be able to calculate the current, right? So how do we do that here? How do we do that? So recall, that is why I say that if you have not watched my second video on electric field, you have to go check out that video out, because I treated how to calculate resistors in series and parallel, right? So now let me just give a rundown. Now when resistors are connected in series, here we have the equivalent resistor going to be arrow equals to what? Arrow 1 plus arrow 2 plus what? Arrow 3, depending on what the resistors connected together. Right there. So now what these are called series connection. Series connection. Right there. So now how do you know series connection? Series connection is when the positive end of one resistor is connected to the negative end of another resistor. If, for example, here I connect something like this. Now this is called series connection. So here going to be arrow 1, arrow 2, and what? Arrow 3. It's okay. So arrow 1, arrow 2, arrow 3, they are resistors connected in what? In series. Just that they are all connected in series. So how do you get your equivalent resistors or total resistor here? Now my total resistor arrow here go to be what? Arrow 1 plus what? Arrow 2 plus what? Arrow 3. Do you understand? So if you checkmate it very well, these two are connected in series connection. They're in series connection. Right there. So when you add them together, so we can just add. You can say 5 ohms resistor and 10 ohm resistors. are connected in what? In series. Are connected in what? In series. Are connected in series. So my equivalent resistor here between these 2 points here, I'm talking about this one here. My equivalent resistor going to be R here equals to what? 5 ohms plus what? 10 what ohms. You give me what? 16 what ohms. Do you understand? So when I connect these two things here, I will now get one resistor which go to be 16 ohms. Now that one will now make to withdraw this circuit again. If I should withdraw this circuit, because of I've already connected this to here, the two of them are now one, right? Which causes 16. So let me withdraw that circuit here. This is what will happen if I should withdraw the circuit. I'm not going to have this one here. Do you see that? So these two are not connected as one to be what? 16 what ohms. To be what? 16 ohms. Now, to be what? 15 ohms. Yes, 15, not 16. Thank you. 15. Here we have what? 15 what ohms, right? Now, this guy is what is 16 is already here, 16 what ohms, right? So, this resistor 16 and resistor what 15. Are they connected? They are connected what in series, in parallel. They are what connected what in parallel. Do you understand? So now when resistors are connected in parallel, how do you calculate the equivalent what resistor? Remember, I also have my 13 volts here, right? So I'm looking for total what current. I'm looking for total current. So how do I calculate resistors in parallel? Now, when resistors are connected in parallel, if for example here we have 3 or 4 resistors, right there, so it will be 1 over what arrow equals to 1 over what arrow 1 plus 1 over what arrow 2 plus 1 over what arrow 3 is okay, depending on what numbers of resistor you get. Now, but if it's just 2 resistor, it's very easy. If it's just 2 resistor, what I'm going to get here, if it's just 2 resistor, now from 3 and above, for 3 and above, this is formula here. But if I should have 2 resistor, you get. If I should have 2 resistor, I can use this one here. I can use arrow here because what arrow 1 times arrow 2 over what arrow 1 plus what arrow 2. So now remember I have 2 resistors connected in parallel. I want to use this one. I want to use this formula here. Easy. You get. But if it's 3 and above, I want to use 1 over arrow 1 plus 1 over arrow 2 plus 1 over arrow 3 to get what my effective what resistor or what total what resistor, right? If you check very well, I only have 2 resistors here because I have 2 resistors. It means that I can use arrow equals to what arrow 1 times arrow 2 over what arrow 1 plus what arrow what 2 is okay. So my arrow 1 will be 16. My arrow 2 is going to be what 15. Can you see that? So I want to write this place out so I can see space to do this calculation. So I'm using what arrow equals what arrow 1 times what arrow what 2 what arrow 1 plus what arrow what 2. Now my arrow 1 resistor 1 is what is 16 ohms. My arrow 2 which called resistor 2 is what is 15 what ohms, right? So what happened here going to be what arrow here equals to my arrow 1 is what is 16 times 15 over what 16 plus 15. So what to do here, so use your calculator here. 16 times 15 divided by 16 plus 15. So going to be what 7.742 ohms. Again, 7.7242 ohms. That is it. So my R here is going to be 7.742 ohms, right? So that got to be what my resistor. Remember, what is our focus here? Our focus is to what is to calculate the total what current, just total current. So since I've already calculated what my total what resistor here, I'm going to get what my total what current. So which one are we using? We are using what? V equals to what? I arrow, right? So making what I is sorry formula here because I look for total current. I is going to be what? V over what? Arrow. Can you see that? So my V is already 13. It was already given to me. So it's going to be 13 over my arrow is what? 7.742. 7.742. So if you should divide it here, 13 divided by 7.742, you have 1.68 amperes. That will not be what the answer. You see that this will what be the answer. So now that is my main issue here is what is to calculate what the total what resistor or resistance. So if I should do that here, then everything will be more easier for me. So let's look at this other one here. Let's solve this third one. We should solve this third one. Now let's look at this one here. They say from the diagram above, calculate what the total current is what in circuit. So they've given me votes here. My vote is what is 12 volts, right? They ask me to look for the currents. Now, how am I going to calculate this one here? So now I need to calculate what the total resistance, right? And this resistance, are they connected in series or in parallel? Of course, they are connected in parallel connection, right? They are connected with parallel connection. Remember, in parallel connection, if we have 1 over what arrow equals to 1 over what arrow 1 plus 1 over what arrow 2 plus 1 over what arrow what 3. It's okay. So what I'm going to do here is this. My arrow is going to be what? 18. My arrow is going to be 12. My arrow is going to be what? 6. So I'm going to have 1 over what arrow equals to 1 over what 18 plus 1 over what 12 plus 1 over what 6. Now, if I don't want to do LCM here, I can do the calculation one by one and sum them together. That is 1 divided by 8 plus 1 divided by 12 plus 1 divided by what 6. You get, so you can easily use your calculator to do this on here. So because I don't want to look for the LCM, I'll just say 1 divided by 8 plus 1 divided by 12 plus 1 divided by what 16. Do you understand? So let's hold up here. 1 divided by 8 plus 1 divided by 12 plus 1 divided by 6. So you're going to be what? It's going to be 0.375. Going to be what? 0.375. Can you see that? So it means that here, let me just use here we are 1 over what arrow equals to 0.375. Let's make arrow the subject of formula here. If you cross multiply, what are you going to do here? Making arrow the subject formula, go to do arrow equals to what 1 divided by what 0.375. Can you see that? So 1 divided by 0.375, you have 2.66 ohms. That is, so my total resistance is what 2.66 watts, 2.66 watt ohms. That is it, 2.66 ohms. That is it. Do you understand? So how do I calculate my currents? How do I calculate what my currents? So remember my vote was already given to me to be what 12 volts, right? So my I is what I'm looking for, right? So here we have what V equals to I what R. Making I so from here we have I equals to V what R. So my V is what 12 volts. Yes, 12 volts over what R is what 2.66 watts ohms. So what will be 12 divided by 2.66? So we have 4.511, just 4.511 amperes. That is it. So you can see how easy it is, right? So let's see. Let me give you some one you are going to solve by yourself before we end this class. Let me give you some questions you are going to solve by yourself. So here we have two assignments I'm giving to you. Right? Here we have two assignments I'll give to you for you to try. Now, although this one is going to tax your brain, so I want you to come out of your comfort zone. I want you to research and try to solve this problem. If you don't have to solve this problem here, leave a comment section that you need the solution to the assignments. Leave a comment section that you need solution to the assignments. But if you have answered it here, please leave your answer in the comment section. Let me know the numbers of persons that will be able to answer this question. Like this one here, there's not complete. Let me see if I can complete this one here. They're going to be 12 votes. They're going to be 12 votes. Yes, that is it. So go ahead and answer this question. If this video is useful and you got a lot of value from this video, please kindly leave a comment section that this video is useful. And which topic in physics do you want to create next? Which topic in physics do you think that which topic in physics that is giving headache you want to create next? Leave at the comment section. Please, if you have not watched the first two videos on electric watt field, please kindly go get those videos. They are free. They will be at the comment section. Thanks for watching. See you in the next video.